Okay, this is the last part in our video lesson for 2.1 in the AP Calculus curriculum, defining average and instantaneous rates of change at a point. We are going to represent the derivative function as the limit of the difference quotient. We're going to find some derivatives at points for a couple of functions. We're going to use the functions y equals x squared and y equals the square root of x. And we're going to evaluate those at several different points. So if we have f of x equals x squared, let's find the derivative at -2. Let's find the derivative at 0. And let's find the derivative at 10. Recall that the limit definitions of the derivative. If we want to find the derivatives at a point, we call it f prime of a, represents the derivative at x equals a. We can find that using the limit as h goes to 0 of f of x plus h minus f of x all over h. Or we could do the limit as x approaches a of f of x minus f of a all over x minus a. Those are equivalent forms of limit definition for a function at a point. So let's find f prime of -2 using both of those definitions. Let's find and say f prime of -2. So -2 is taking the place of a. So that's equal to the limit as h goes to 0 of f prime of x plus h. That is -2 plus h squared if f of x equals x squared. And that's minus f of -2 squared. Let's see here. Oh, and this should be a instead of x. My bad here. So that's going to be -2 squared all over h. This is the limit as h goes to 0 of -2 times -2 is 4. -2 times h plus -2 times h makes -4h, and then h times h makes h squared minus 4 all over h. 4's cancel. Oops, didn't mean to cancel the h. So this ends up being the limit as h goes to 0 of -4h plus h squared all over h. When we divide that, we get the limit as h goes to 0 of -4 plus h, which equals -4. So this, according to this, the limit or the derivative of f of x at -2 is equal to -4. Let's apply this other definition and see if we get the same thing. So we have f of x, which is x squared. Oops, forget the limit. Limit as x goes to, in this case, we have -2 is a. F of x is x squared. And f of a, that's going to be x -2 squared. So we're going to minus -2 squared is 4. This is going to be x minus a is -2. So it's going to be x minus -2. So this equals the limit as x goes to -2 of x plus 2 times x minus 2 over x plus 2, which equals the limit as x goes to -2 of x minus 2, which is -4. So the derivative as x goes to -2 of f prime of x when f of x is x squared is -4. We showed that using both of those. I'm going to erase that, and we're going to do the next one. This one we'll only do one way, and then we'll do the other one the other way, using the other definition. Once you solve it, they both work, give you the same answer. No need to do everything twice. Clean this up a little bit too while we're here. Okay, so now we're going to find f prime at 0. So f prime at 0, we use the first definition for this one. It's going to be the limit as h goes to 0 of f of 0 plus h minus f of 0 all over h, which equals the limit as h goes to 0 of 0 plus h all squared, which is f of 0 plus h, is going to be h squared, and then minus f of 0 is going to be 0, and that's all going to be over h. And this equals the limit as h goes to 0, of h minus squared minus 0 is just h squared over h is just h. So the limit as h goes to 0 of h is just 0. And that's true, that the derivative, remember we said a little while ago that the derivative, or we said in one of the other videos, that the derivative is the slope of the tangent line. And if you look at the graph of y equal x squared at 0, tangent line is the x-axis. It's a horizontal line, so it has slope 0. So it makes perfect sense that f prime at x equals 0 is 0. Let's go ahead and find f prime of 10 using the other definition. So we're going to find f prime of 10, and we're going to say the limit as x approaches 10 of f of x, f of 10, f of x minus f of 10 over x minus 10. And this equals a limit as x approaches 10 of f of x is x squared minus f of 10 is 100. That's over x minus 10. And this equals the limit as x approaches 10 of x plus 10 times x minus 10 over x minus 10, which equals the limit as x approaches 10 of x plus 10, which equals 20. And so f prime of 10 is equal to 20. If you look on your calculator, there's a numeric integration that you can go to. Let's go second quit. Let's do math or derivative. Well, not sure what's going on here. Let's try this. All right, the calculator application's froze, so we're not going to use that. It's froze. So I'll teach you another time how to find numeric derivative on that, or I'll link a video to it or something. So that's how you find the derivative of y equals x squared, several examples. Now let's go ahead and let's do this for y equals square root of x. Same kind of thing. I'm going to erase this now. We can't do f prime of negative 2 because the square root of x is not defined at x equals negative 2. So we're going to have to change those. Just do a couple of examples with this one. Remember, the derivative at a point is the slope of the tangent line at that point. The derivative has lots of applications. That's one of them. And you're going to be asked to identify that and to use that to identify other things. So you need to know that the derivative at a point is the slope of the tangent line. We're going to wipe this one out. We're not going to be able to do it at 0 because that limit will only be one-sided. So we're going to consider another place where it's one-sided. Let's do f of 1. How about that? F prime of 1. If we think about the graph of this function, the square root function goes like this, defined from 0 to infinity. So slope of the tangent line at x equals 1, I missed that, but that's it. And the slope of the tangent line at x equals 10 is what we're looking for. So again, let's just do this with 1 each way to keep the video from being too long. Let's evaluate f prime of 1 using the first limit definition of a derivative. So we're going to do f prime of 1 is equal to the limit as h goes to 0 of f of 1 plus h minus f of 1 all over h. That's going to be equal to, this is, f of x equals x, square root of x is what we're looking at this time. So this equals square root of 1 plus h, our limit of h as h goes to 0, square root of 1 plus h minus the square root of 1, which is just 1, right, over h. This square root of 1 plus h minus 1 over h. I still have to have the limit. Can't lose the limit. Can't lose the limit. Now, the trick here to show what we're going to need to show is to rationalize the numerator. You may have rationalized the denominator in the past, but now we're going to rationalize the numerator. To do that, we need to multiply the numerator and denominator by the same thing, and it's going to be the conjugate of the numerator if we're rationalizing, this 1. If we multiply the denominator by that, we have to multiply the numerator by that so that we're really multiplying by 1 and we're not changing the value of anything. When we do this, we're still going to have the limit as h goes to 0. And we're going to have to multiply square root of 1 plus h times square root of 1 plus h, multiply the square root by itself, we get 1 plus h. And then when we multiply 1 plus square root of 1 plus h times 1 and the square root of 1 plus h times negative 1, those cancel out. Then we end up with negative 1 plus 1, or negative 1 times 1, which equals negative 1. And that's all over h times square root of 1 plus h plus 1. That equals the limit as h goes to 0. 1's cancel, leaving with h in the numerator, over h times square root of 1 plus h plus 1. That says plus 1. Can't get my finger right. The h's cancel, leave me 1 in the numerator, so this is the limit as h goes to 0 of 1 over square root of 1 plus h plus 1, which equals 1 over the square root of 1 plus 1, which equals 1/2. So the derivative of f of x equals the square root of x at x equals 1. F prime of 1 is the derivative of f of x at x equals 1. That's equal to 1/2. Now let's use the other definition of the derivative to find f prime of 10. And so this equals the limit as x approaches 10 of f of x minus f of 10 over x minus 10, which is the limit as x goes to 10 of the square root of x minus the square root of 10 over x minus 10. And again, we're going to rationalize the numerator this time to evaluate this limit. So we're multiplying top and bottom this time by the square root of x plus 10, the conjugate of the numerator, what we're trying to rationalize, times the square root of x plus 10. And when we do that, we're going to end up with the limit, as h goes to 0, or sorry, as x goes to 10, of, we multiply square root of x times square root of x, we get x. We multiply square root of x times 10, we get 10 square roots of x, and negative 10, sorry, we get, that should be the square root of 10. That's got to be the square root of 10. And that's got to be the square root of 10. My bad. With the square root of 10 times x, square root of x, and the square root of 10 times square root of x times negative square root of 10, those cancel out. And then I have the negative square root of 10 times positive square root of 10 makes minus 10. And this is all over x minus 10 times the square root of x plus the square root of 10. So these cancel. I'll leave you 1, and we end up with the limit as x goes to 10 of 1 over the square root of x plus the square root of 10, which equals 1 over 2 square roots of 10. And the limit, or sorry, the derivative of f of x at 10 is going to be 1 over 2 square roots of 10. And those are some examples to calculate derivatives at several points.